Well, hello, hello. How are you, Leanne? You're not late. You're just in time. I just came on. No need to freak out. Am I late? You are right on time. All right. Well, hello, everyone, and good evening. Hopefully you guys are doing well. I'm so glad that you are here. So, as promised, we are going to be working on systems of equations. So, first go around is we're going to do some graphing. Try to bring that back into play. So, I'm going to turn my music down a little bit. Make sure you guys have everything that you need. And this is where I need help. Okay. Gotcha. Hello, Willie. How are you? So, if anything, let me see if I can zoom in just so you can kind of get the formulas down. Let me take a quick little zoom. All right. So, what is a system? So, a system is basically two or more equations, and we're trying to find the solution. So the solutions are either going to be an ordered pair where the two or more lines intersect, or they're going to be lines that don't intersect at all, which is called parallel lines. So we don't have a solution. Or they're going to be lines that overlap each other. So when they overlap, they're basically the same slopes, the same y-intercepts, the same coordinate points, and it's called infinitely many solutions. Because when a line is laying on top, let's see if I can use my pencil, and I have another pencil laying on top. Oh, this will be talented if it stays up. And it won't. So if you have two lines basically staying on top of each other, all the points, all the coordinates are going to be exactly the same. But if we have two lines and they intersect, they're going to have what's called a point of intersection. That's going to be its solution. But if I have two lines that have the same slope, but different y-intercepts, okay, they're not going to intersect. They're parallel, so they do not have any solutions in common, right? So hopefully the pencils kind of helped you a little bit there. So where you look at it, it kind of looks like this. Just regular two equations that can be in standard form, or you can have one equation that's going to be in slope-intercept form. But no matter what, you can solve it one of three ways. So we can solve it by graphing, or we can solve it by substitution. So what I mean by substitution, so if I have this pencil, wow, and say I want to substitute that pencil for this purple pen's coming into the game, pencil is coming out. That is a substitution. If you want to think of it like food, I'd rather have a baked potato than French fries. Yeah, realistically, it's the other way around. But there is, well, sometimes you get the bonus of a little bit of a fry that kind of sneaks in there. But really, when you substitute, all of it comes out and all of it goes in, okay? So if someone's substituting into a basketball game, they're not leaving their ankles or their wrist or a finger on the ground. They're putting all their whole body into the game, and the other person's taking their whole body out of the game. Unless you played against me. And yeah, that was probably the whole gist. I was very aggressive. All right. Hello, how are you? All right. So what we're going to do first, we're going to look at it from a graphing perspective. And after we look at it through graphing, I'm going to show you through substitution. So we're going to try to get these two down. All right. So in order for me to do this through graphing, first off, look at my equations. My equations, we can do this one of two ways. One way is going to deal with what's called the intercepts. Okay, so if I need to find the x and y intercepts. So if I take a look at the first equation, so we have 3x plus 4y is equal to 12. If I wanted to use the x-intercept, so that means I'm going to substitute 0 for my y's. So I'm going to put a 0 for my y's, so that means I have 3x plus 4 times 0 is equal to 12. Anything times 0 will give me 0. Now I have 3x is equal to 12. And if I divide both sides by 3, I'm going to have x is equal to 4. So my x-intercept is going to be 4, 0. Okay, and we can use that point for our graph. If I want to find the y-intercept, so I'm going to stick I'm going to go right underneath. I'm just going to save this whole page for this. So if I go with the same equation, but if I want the y-intercept, that means my x value is going to be 0. So the y-intercept, the x is going to be 0. The x-intercept, the y is going to be 0. So now 3 times 0 gives me 0. That means all I have to do is bring down my 4y equals 12. And if I divide both sides by 4, I have y is equal to 3. So the coordinate for that point is going to be 0, 3. All right. Okay. Hey, thanks for the follow. Hey, misbehaving. How are you? Yep. So linear combinations, that is elimination. And we're not doing linear combinations tonight. Yes. So some schools, some books put it as linear combinations. Some people call it elimination. And some people call it something else. There's a third one that's starting to evolve. I don't know. It's just like we're basically trying to find the same. Okay. And do you have to find both? Yes. So you will have to find both. Okay. So now we have the coordinates to help us graph that first equation, that 3x plus 4y equals 12. So now we're going to do the same thing, but for the second equation. So if we do that, I'm going to change colors so we know the difference of the two. So if I wanted to find we have 2x minus 3y is equal to -9. And if we want to find the x-intercept, that means we're making our y values equal to 0. So in that case, we have our 2x minus 3 times 0. And we know that's going to give me a 0. So I have my 2x is equal to -9. Divide both sides by 2. And your x is going to equal to a negative, was that 4.5? So the x is going to be negative 4.5, 0. So that's going to be the x-intercept where it crosses the x-axis. Yeah. Why isn't it 1? Why isn't what 1? Leanne. Why isn't it 1? Oh, do you mean like why isn't x and y equal to 1? I think that's what you're asking. Because the variables, okay, the variables are not just 1. The variables can be any number. The coefficients of those variables, if you don't see an x or a y, it will be a 1. Okay? Okay. So I know a lot of teachers do that, and it drives me nuts because they always say, oh, if you see X, X is 1. No, X isn't 1. X can be any number that needs to make this equation into a true statement. So when you see X and you don't say you didn't see this 3, that 3 wasn't there, and it was just an X, it's assumed to be a 1 in front of it as the coefficient, not the value of X itself. That's what we're trying to find. Okay, makes sense? Why don't you put 0, not 1? I think she's asking, why do you put zeros, not ones? Oh, because we're using the x-intercepts. The x-intercept, your y value is going to be 0, not 1, because this is where it crosses on the x-axis. If it crosses on the x-axis, your y value is going to be 0. Hello, Mahogany. Same thing goes with the y values. If I'm using the y-intercepts, so when it crosses the y-axis at the start, your x value is going to equal to 0. So we're just using these to find that. Okay. So now if we're going to try to find the y-intercept, we have our x's are going to equal 0. And when I graph it, you'll probably see it a lot better. Okay, so we're doing the y-intercept. So anything times 0 is going to be 0. So it brings me a negative 3y is equal to negative 9. Okay. Thank you. So divide both sides by negative 3. And then y equals a positive 3. So the order pair for this is going to be 0, 3. Okay. So these are going to be my x and y intercepts for the bottom equation. And these are going to be the x and y intercepts for my top equation. So now let me get you graphing. So it looks like 4s and 5s. Okay, so I can make a nice little graph. Oops. I'm going to probably slide it over to about here. From this point to roughly this point. And since we're looking at negative 4.5 and 3s, I think this will be good enough. So we're going to go from, oops, adding a little too much pressure on one side than the other. So from here to here. Okay, there's my y. There's my x's. Let's see if I can get that. So here's 1, 2, 3, 4, 5, 6, 7. Negative 1, negative 2, negative 3, negative 4, negative 5. Negative 6. 1, 2, 3, 4, 5, 6, 7. I don't think we have to go that far. 2, 3, 4, 5, 6, 7. So this is a positive 5. This is a positive 5. This is a negative 5. This is a negative 5. Okay. So we have our graph. Is this college algebra? Systems of equation is in college algebra, but this also could be in algebra 2 and also some advanced algebra 1. Okay, so it's algebra. Let's summarize this as algebra. Okay, so now we are going to plot our 2 points. Okay, we have 4, 0. So my x value, if I start at the origin, my x value is a positive 4. Notice my y value is a 0 because this is when y is 0 and x is 0. But over here, this is when x is 4 and y is 0. Do you see why it's a 0 and not a 1? Does that make it a little bit clearer? Okay. So if I go to 0, 3, I'm starting here at the origin. Okay, I'm not going left or right because my x value is 0. And then I'm going up 3. Okay, so I just need at least 2 points. When I got 2 points, now I can draw my line. Okay, so that's representing, this line is representing my first equation, and we're using the intercepts. Now for the second equation, I'm going to raise it up a little bit, or a lot. Okay, we had negative 4.5, comma 0, and negative 3, comma 0. So for negative 4.5, here I'm starting at the origin. Negative 4, that means I'm going to the left. 0.5 is right smack in between 4 and negative 5, or negative 4 and negative 5. Okay, so that's my first point. 0, 3, I'm starting here at the origin. I'm going up 1, 2, 3. Hey, that makes life easy. We're right there sharing a point with that first equation or first line. So if I draw my lines, got a little crazy with that line, but when I draw my lines, notice they have a point of intersection. So my point of intersection, and change colors here. So we got point. So where they cross is at 0, 3. So that point of intersection is also known as your solution. Okay. So that's what we're looking for. We're looking for where those two equations is going to intersect at a common point. Okay. How are we feeling? Okay. Using the intercepts sometimes work. Sometimes finding the equation of the lines work just as quicker. Of course. Let me unzoom. Let's see. We might have to take 2 pictures. So let me slide over so you can get the instructional piece. Okay. All right, ready for the other side? So like if I do this, will this work? Let's see. Can you see the whole thing? Okay, so when any number we can use 0, like your examples. So you can use the x-intercept. The x-intercept is basically when your y value is 0. And then you can use the y-intercept, and that's when your x value is equal to 0. So you can definitely use those. Okay, all right, not a problem. Yep, so you can use the intercepts to actually graph these. Now, here's another one. Like I said, you can, let's see if I can use the back side. Yep, I can. same problem, but I'm going to show you it's basically the same graph. If I take each of the equations and I decide to solve it for y, aka put it in slope-intercept form, okay? You can do that. So slope-intercept form is y equals mx plus b. So I want to solve the first equation for y. First thing I need to do, I need to subtract that 3x because we want to isolate for y. So whatever I do on one side of the inequality, equal sign, I do on the other side the equal sign. So if I subtract the 3x, now I got 4y equals, and you could say 12 minus 3x. I like to put it in slope-intercept form. So negative 3x plus 12. The reason why I can't combine these two, because 12 does not have an x, but the negative 3 does. Okay? So now I want to get y by itself. So I would definitely need to divide everything by 4. Okay? All right? So we're just isolating our variable. Okay? We're isolating our y. So right now, you are the y. Your boo is the 4. Here is a couple 3x trying to kind of throw themselves into your plans of just having fun. So you need to eliminate them away from you. Get them away from you. So since they're a positive, we have to do the opposite. Make it negative. So then when we cancel out, we bring down that 4y. So now I'm bringing my negative 3x plus the 12. So they're having fun on the other side. But now your boo is driving you crazy. You got to delete them or divide them out of your life. So now when you divide everything by the 4. So that means 4 divided by 4 will give you 1y or just y. Bring down the equals. Now, negative 3/4 x, you can leave as a fraction because that is your slope. And remember, slope is a fraction. Rise over run. So you want to keep it as a fraction. Plus x 12 divided by 4, that will give me 3. And this 3 is your y-intercept. She brought the x to the right to get in slope-intercept form now. Yes. So basically, I'm trying to put it into this slope-intercept form. Okay. Why would you add 12? Because if I move the 12 over, it's not balanced. We always want to balance out. The goal is to get y by itself, not the 12. Okay? It's a very long process. Well, this is two different processes. The first one did with the intercept, and then this one we're doing with the equation line. Because the 12 is by itself, it said 12x, you would subtract. Okay. Hello, Chris. How are you? Okay. All right. So if we take a look, y equals negative 3/4 x plus 3. If I look at that graph, which was the first equation, didn't we start here at 3? That's my y-intercept. So for me to do the slope, I would go down 3, 1, 2, 3, and over to the right 4. 1, 2, 3, 4. Huh, look at that. We already have it pointed there. Okay? So we have our y-intercept. We figured our slope was -3 over 4. So from the y-intercept, we go down 3 and over to the right 4. And we found the point. So you can either basically solve the equation for y, or you can use the x and y intercepts. I'm just showing you. I know it seems like very long for one problem, of course, because I'm doing it 2 different ways. All right. So you have a choice. You get to pick which way you want to graph. All right. If you don't believe me, let me take the other equation. So 2x minus 3y equals -9. If I wanted to solve that one, I have my 2x minus 3y equals -9. So I want to solve my equation for y. So that means this positive 2x needs to go away. Get them away from you. You just want to chill in the club, but here they come. I want to be all happy and in your business. So now subtract them out of your life. They cancel out. So now you have a -3y is equal to -2x minus 9. So I want to get them equal to y. So we're going to divide everything by -3. So I can get y by itself. I set them equal to 0. Yeah, no. This is linear. Setting equal to 0 is only for quadratics, okay? So this is for linear. So once we get our y's equals, a negative divided by a negative will give me a positive. So it's a positive 2/3 x. And we can leave it as a fraction because the number that is next to your x is your slope. That's your rise over run. But over here, we have a -9 divided by a -3. A negative divided by a negative gives me a positive. And 9 divided by 3 gives me 3. So the equation of the other line is 2/3 x plus 3. Let's take a look. Here we are at plus 3. 2/3, that means I'm going up 2 and over 1, 2, 3. Right there. Okay, so you can use either the x and y intercepts to graph your points, or you can solve both equations for slope-intercept form and then graph them on the same grid. Okay? Yes, linear equations. Hi, Eric. Or Eric. All right. All right. Questions. How are we feeling? You're basically graphing not once, but twice on the same grid. That's what happens when you're dealing with systems. Is it possible you can do another graph to find the point of intercept? Of course. Okay. In prison. Hey! I used to teach at our juvenile justice system. We called it baby bookings. So I totally get it. All right, a little better? Okay. All right, so let me take this away. My other books are coming because I ran out of pages because we keep doing some awesome stuff here. All right, so based on you seeing both processes, doing the intercepts or solving the equations in slope-intercept form, which would you prefer? Which would you prefer? So would you like the intercepts, or would you like solving it using slope-intercept form? Slope-intercept form. Let's see if we got this one. And I'm going to pick the majority, so... Okay, so Leanne saying slope-intercept form. Nay saying intercepts. Okay, who's going to be the tiebreaker? Okay, there's roughly like, what, 31 in here? What would you prefer? The equations or the intercepts? It's going to be up to you, because I'm only going to do one way. Okay, so I got one with the slopes. Got two of those. So misbehaving like the slope-intercept forms or the intercepts? What's the difference? Well, Wolfie? One, you have to find the x and y's for both of the points. The other ones, you just find the equations. Hello, Queen. Okay. So I got two for the slopes intercept form, one for the intercepts. All right. Elimination. We're not doing elimination. What you doing? I appreciate that. Not a problem. All right. So it seems like slope intercept form has won. So we have the first equation, which is negative x plus 2y is equal to 8. So we want to solve this equation for y. Let me see if I can zoom in a little bit so we can stop squinting. All right. Oh, thanks for the love. All right. So we're going to add one what? What's missing, 9? What's missing? Okay, so we want to get y by itself. There we go. Good. So there was a minus x. So the opposite of minus is plus. Whatever we do to one side equal sign, we must do to the other. It's all about balance. I'm a Libra, so it works for me. Okay, so we cancel those out. What comes down is my 2y equals, and I can't combine the 8 and the x because they're not like terms. The 8 doesn't have an x, but the x is an x. So I'm just going to write it down. And I'm trying to keep it in that slope-intercept form. If you decide to put 8 plus x, that's fine as well. Okay, as long as you know that that 8 right now is your y-intercept. Until we do what's next. Yes. Is it Jamie? Or Jermaine? Okay. We divide everything by 2. Okay. So we're going to divide everything by 2. What's wrong? It's a negative. Or that's wrong. It's a negative 2. What's a negative 2? No, it's not a negative 2. Why would it be a negative 2? True. Yeah. Anywho, so we're dividing both everything by 2. So now we got y is equal. Now, here's that thing. I think it was Leanne. What's in front of our x? What's assumed to be in front of our x? Okay, good. A 1. So in actuality, it's 1 divided by 2. That's the same as saying 1/2 x. Okay, we see that? Good. Ah, Tears Blonde, how are you? Okay, so there's a 1 in front of that x divided by 2, so 1/2 x. We want to keep it as a fraction because that's our slope. Now, plus 8 divided by 2. What would that give me? Okay, there we go. Thank you, thank you, thank you, thank you, thank you. Oh, drop that question mark. It is a 4. Good job. All right, so this is the equation for that first problem. Okay, how are we feeling? Okay. So now, let's do that second equation. So we have 2x minus 4y is equal to 5. Not a problem. Good. Very helpful. Oh, good. Glad you're finding it. Hello, Micah. Why did you divide 2 by x and 8? Why didn't you divide x plus 8 by 2? Okay, so when you divide everything by 2. Because this is what we as human beings do. We will divide the 8 by 2 and get 4, but we'll forget to do the division. So what I like to do is I like to divide every term by the 2 so I won't forget. Okay, so we got it in, just like Micah mentioned, we got it in that standard form and we're trying to transform it into that slope-intercept form. Okay, does that make sense, Tears? Hey, Law. Okay, so it's because you're trying to get it in standard form. I'm trying to get it in slope-intercept form. I'm trying to get it in this y equals mx plus b. That's slope-intercept form. Okay, standard form is what the original one is. This ax, well, let me put it up here. Ax plus by equals c. This is standard form. This is slope-intercept form. Okay. All right. So, let's go the one in the red. What do I do first to solve this for y? Tiffany, I don't understand how this method translates to drawing the graph. Or you don't draw the graph. Well, we have to put it in slope-intercept form to draw the graph. Yes, so we're going to subtract the 2x on both sides. Because if you're going to stay in standard form, that means you're using the intercepts. But we wanted to use, or they voted to use the slope-intercept form. Okay, I'll subtract 2 on both sides. So we're going to subtract the 2x on both sides. So we bring down the negative 4y equals negative 2x plus 5. Okay, we can't combine the 5 and the negative 2x because the 5 doesn't have an x. They're not like terms. So if you can't break them down, just bring them down. All right, I know this isn't about the topic, but can you please make a video? I did already. You can go to multiplying, dividing, radicals. I don't think I did the dividing, but I know I did the multiplying. It's on my YouTube channel, Audrey Codner. Okay, with variable. I don't know if I did it with variable. I think I did it with variable with somebody last week, but I can see what I can do. but it's definitely not going to be tonight. We want to divide all the terms by what? Too tough? Too tough, Nikki? Okay, you want to divide it by not just 4, but there you go, -4. Yeah, so remember, there's a negative. That minus sign is attached to that 4. So it's acting now as a negative. So we want to divide everything by the -4. So here's the key thing, guys. Make sure you know that the signage of your number is always to the left of the number. Like the sign of my 2x, it's a positive 2x because there's no negative in front of the 2. This 4 is really a -4 because the signage. This 5 is a positive because there's no minus sign in front of it. So the signage is always next to the left of the number. So now these -4's cancel, giving me a y equals. So -2 divided by -4. Okay. Do you include the y? When I divide, I do not include the y because we're trying to solve for the y. Okay, careful, guys. It's not 4 divided by 2. It's 2 divided by 4. Okay. But we all know it's going to be positive, so I got that. Okay, do you cross multiply? No, you can't cross multiply when you have 2 terms on one side and 1 term on the other. Okay, it's not a positive 2, it's a positive 1/2. Because it's 2 divided by 4. Okay, not 4 divided by 2. 4 divided by 2, that will give me a 2. But it's 2 divided by 4. So it's going to give me a 1/2. All right, good. So 1/2 x. Excellent. Now, my y-intercept, we have a positive 5 divided by a -4. I was thinking, but it was in the fraction form. Yes. Okay. I'm lost. Okay. So, you have your equation. You subtract the 2x on both sides. The -4y comes down. -2x, positive 5. I can't combine these because they're not like terms. So now I want to divide everything by 4. By -4. I don't want to divide by -4y because I'm going to cancel everything out over here. And that's not what we want to do. We want to solve for y. So that means I need to get rid of that -4 so I can isolate my variable. All right. Okay. So now we have a negative divided by a negative, which gives me positive. And 2 over 4 can be simplified. So 2/4, what they both have in common is 2. So 2 divided by 2 gives me 1. And 4 divided by 2 gives me 2. That's where the 1/2 came from. Right. 0.5 is the same as 1/2. Can I still use this as a point? I wouldn't because that's your slope. Because you're going to graph. It's kind of hard for you to graph 0.5. Right? It's easy for me to graph up 1 to the right 2. Okay. But then multiply removes the fraction. Okay. So 5 divided by -4. Positive divided by a negative will give me a negative. So with your 5 divided by 4, you can use that as a decimal if you want, which is going to be your 1.25. Since this is my starting point on my graph, it's easier for me to plot roughly where 1.25 is going to be instead of 5/4. Okay, you're caught up? Awesome. How? How what? Leanne, how what? Okay, 1.25, 5 divided by 4. So if I have my 4, I have my 5. Only one set of 4s can go into 5 without going over. Then you have 1 left. It gives you a remainder of 1/4. 1/4 is the same as saying 0.25. Yes, yes. So Tiffany, that is going to be your starting point. Yep, $1.25 if you think quarters. Top in the box. Okay. All right. Okay. Okay. All right. So now we have our 2 equations. So with our 2 equations, let me see if I can unzoom a bit. So we're going to start here. And we can come over to here. Just a straight marking. All right. So this is my y values. This is my x-axis. So I got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. All right. So, first equation, which I'm going to do in blue. What is my starting point for this first equation? Put in the chat. Okay. What is my y-intercept for the first equation? Okay, what will be my starting point? Okay, we got Lexi. Is it Lelucia? Okay. My name, Jeff. Tiffany. Okay. So remember, your starting point is always your y-intercept. And our y-intercept in this case is 4. Anytime you're about to graph, you always start at the y-intercept. You always start at the b. Okay? So on the y-axis, my first point is going to be at 0, 4. Okay? From this point, I'm going to look at my slope. My slope is 1 over 2. So remember, slope is rise over run. So I'm going to rise up 1, and then I'm going to run, since it's a positive 2, to the right 2, and make my point. I could repeat this process again. I can go up 1 over 1, 2. Up 1 over 1, 2. Okay, you see how it's forming a line? Okay, I'm going up 1 and over to the right 2. If I want, from my starting point, I could go down 1 and to the left 2. Notice that's still on the same line. All I need to do is make it double negative, going down 1 and over to the left 2. A negative times a negative still gives me a positive slope. Okay? So if you're good with going one way, you can go one way. Then I draw my line. I would have started at the 1. I don't know what the obsession is with 1. Okay? It's not 1. It's always whatever the y-intercept is. Okay? I know we're so used to like that's what I start with to count with. But when it comes to graphing, once you find out what your y-intercept is, that's exactly where you start every time. Okay? So if my y-intercept was 3, like the other one is, I find the 3 on my y value and put that first point down. Okay? All right? So I'm finishing up on this one, and then I have to go to my next point. Okay? Got to come one time. All right? So, trying to see. And you can plug that point back in to double check. Yes, you can. You can plug it right into your equations. So, find the derivative. No, we're not doing that. Another one. I love how everyone's saying do another one. We're not even done with this one. We ain't done. All right? We just graphed that first equation. Y'all forgot about the second one? I was saying do rise or run on to the second one. I would have thought you start with 4. So for the second one, where would I start for the second one? Okay, where would I start? Well, hello. How are you, Raquel? Yes, Lexi. Yes, John. Okay, make sure those are negatives 1.25s. So, we're starting at my y-intercept, which is at negative 1.25. So, right here on the y-axis coming down, here's negative 1. So, negative 1.25 is not going to be halfway because that'll be negative 1.5. So, it's about a quarter of a way. If you make your dots large enough, you could probably get away with it. That's what most people do. So here's negative 1, here's negative 2. Negative 1.25 is just under negative 1. Okay? Now, from this point, we need to look at our slope. Our slope is a positive 1 over a positive 2. That means I got to take one full step. And the full step is not just going to the negative 1. That's not a full step. If I'm starting here at negative 1.25, a full step will be here at negative 0.25. That's going up 1. And now I go over 1, 2. And I put my second point here. Okay. So if I want to go up one full step, I'm going to go up one full step. And now I'm going over 1, 2. And I draw my point. And remember, all you really need is 2 points. If you get 2 points, you can go ahead and draw your line. What do you notice? Why negative? Because there's a minus sign in front of the 1.25. That's why. Okay, good, Lexi. Parallel, good, Layl. Yes, there's no solution. Hey, Native, they're parallel. Yes. Tiffany, they're parallel. They do not intersect. Yes. So we do not have an intersecting point. We do not have a point of intersection. Okay. So they don't have any points in common because they are not intersecting. Now, I knew they were going to be parallel, not because I put these numbers together, But as I was solving, I knew that there were going to be parallel. What told me, based on the equations, what told me that they were going to be parallel? Oh, thank you. What told me that they were going to be parallel? They're not. Oh, hey, Lisa. They're not a function. Not so much the function. Oh, wait. Is that Kaya or Kia? Saying slopes are the same. Okay, the slopes are the same. Take a look. For this equation, my slope was 1/2. For the red equation, my slope is 1/2. When the slopes are the same, you're going to have parallel lines. So if you ever come across and you know the calculations and you notice that your slopes are exactly the same, and you look at your answer choices and they just say parallel lines, you just mark that one. Okay? Yep. Same slopes, but different y-intercepts. Correct. Okay? So it didn't have to do anything with the y's. You're just basically looking at the slopes. Okay, so there is no. Okay, some people will say there is no solution. And the reason why, they're not crossing. They're not intersecting. Ooh, look at you, Micah. Yes, inconsistent. Good job. All right. How are we feeling? Okay. Thank you so much for the likes and the hearts and everything. This is awesome. All right. So when you get a system, majority of the time that you guys will probably see, well, maybe you may or may not. The majority, sometimes you'll see with system of equations is either 2 equations, and there are times that you'll see 3. Okay. Yes. Good. All right. So sometimes you may see 2 or 3 equations. Very rarely you'll see more than that unless you're doing like advanced math. There's a possibility for seeing it in maybe AP. Okay. All right. All right. So this is how you graph a system of equations. You either can use the equations of y equals mx plus b, or you can find the x and y intercepts and then go ahead and graph. All right. So now we're going to be looking at substitution. Okay. And that'll be the last thing that we are doing this evening. So if we're doing a system, okay, today's the what? 24th? Okay, 2/24. 20. Ooh, 25. Ooh, tomorrow's going to be a magical day. Okay. All right. So when we are looking at doing substitution, this is the easiest way that I can say it. So let's get with the first example. Let's say we have 3x minus 2y equals 1. And we have x plus 4y equals 3. Now, anytime they give me 2 equations, and I notice that one of my variables, either the x or the y, is by itself like this, that means I want to take this second equation and solve it for x. Okay? I want to solve it for x, so it will be x equals. In order for me to do that, that means I would have to subtract, I would have to subtract that 4y on both sides. Okay, how are we doing? Okay, why subtract? You always got to do the opposite, Sarah. When you're solving equations, you have to do what's called the inverse. Okay, always have to do the opposite of what you see. So if it's plus, the inverse is minus. If it's multiplication, the inverse is division. If it's division, the inverse is multiplication. So you always have to do the inverse. Lost like always. So just see if you can follow along. So if anything, we're trying to solve for x. We want to get x by itself. Right now, that 4y is on the same side as the x. Okay, remember, we're using the equal sign as a barrier. So I would need to subtract 4y on both sides so I can get the x by itself. So it can be x equals, and then I plug in my 3 minus 4y. The reason why I'm doing this is I'm telling you guys that x is being represented by 3 minus 4y. So if I need to substitute, that means this 3 minus 4y, I'm going to substitute it for the x in the top equation. The reason why is because this is x equals. So I'm going to take this information and I'm going to plug it in for x. So it's going to look like this. There's a 3, and I'm going to put a parenthesis because that's where we're going to put the information. Then it has a minus 2y equals 1. And inside this parenthesis is going to be 3 minus 4y. Okay. All right. When substituting, you can either get x or y by itself. It doesn't matter. Exactly, Luke. And how are you? Okay. Then we're going to distribute. Yes. Okay. The reason why we're doing this is we're trying to find the point of intersection. We're trying to find the x and y value that's going to be the cross section of these two equations. So we're doing the substitution to help solve for one of the variables. If you notice, the only variable that's being represented in this equation is y, right? So by solving that second equation for x and plugging it in for x, we take out that x and we put in the y, okay? Felt like Shogun for a second, like push in, pull out. All right, so now we're going to distribute. So we're going to take this 3 and distribute to everything inside the parenthesis. We're not distributing to the negative 2y, just what's inside the parenthesis. So now 3 times 3 gives me 9. 3 times negative 4y gives me negative 12y. And then we bring down the minus 2y equals 1. Okay. So 9 plus 12. So we do have a 9, but it's going to be a negative 12. And it's a negative 12y. Okay, DJ, she put x by itself since x was already itself, so it's a lot easier. Yes. Now we only have one variable to solve for. Yes. Do you combine like terms? Yes. Why did you subtract, not add? Why did I subtract, not add? Because the original was a positive for y. The inverse is a negative for y. Okay. So why was the 4 negative? I'll repeat. Because the original 4y was a positive, you have to do the inverse, the opposite, in order for them to cancel out. Okay? In order for you to have $0, you start off with $4, you spend $4, you don't have more money. You're trying to get arrested. All right? So if you have $4 and you spend $4, you have no money left. So in order for these to cancel out, the signs have to be opposite. Okay? All right, so we're going to combine like terms. Why would you solve differently if they has parentheses? Try again. So, like terms, negative 12y minus 2y. That gives me a negative 14y. And why is that negative 14? Both signs are the same. Anytime they're the same, you just bring down that sign and then you combine, then you add. And then we bring down the 9 that was in front. Okay. PEMDAS. Yes, P stands for doing the parentheses first. True. But do I have any like terms inside that parenthesis to combine? Okay. Excuse me, do you teach at school because you're good? Some students need somebody like you. I used to teach at school for 22 years. And then I decided to have my own tutoring business. I would say 10. You would say 10, but the 12 is negative and the 2 is negative. So if I owe $12 and now I owe another $2, guess what? I owe $14. Okay, okay. All right. So signs are the same. It's going to give you negative. You're going to be adding. So now we're actually going to subtract this 9. So the 9s are going to cancel out. I got a negative 14y. Negative 14y is going to equal what? Okay. So we got Micah with negative 8. Okay, once you do the parentheses, do you go left to right or you still use PEMDAS? Because I did a practice test wrong. So after you do the parentheses, you are basically, like you said, you're combining your like terms. So when I combine my like terms, that's going to be my y's. That's where the negative 14y comes from. Bring down the 9 because we're not simplifying an expression. We're solving an equation. So we always want to do the inverse. So we got our negative 8. Good. So now divide both sides by negative 14. So the 14s will cancel out, gives me 1y, or just y. And negative divided by negative will give me what? Yeah, oh, I'm fine. Yeah, I appreciate that, Taylor. Not a problem. I'm so used to it. I'm like so numb to it by now. I mean, 22 years in the classroom, especially high school, I'm used to it. All right, so it will give me a positive. So a positive 8/14, which, yes, I saw someone that says reduce. Yes, we do want to reduce. What number does 8 and 14 have in common? Okay, they're both even. So what number do they have in common? True, they do have 1, but what else do they have? They have 2, not 4, because that's a 14. If that was a 12, the 4 would be the best one. So 2 is going to work for us. So basically you're dividing. When you simplify, you're basically dividing, making it smaller. So 8 divided by 2 gives me 4. 14 divided by 2 gives me 7. So our y value is 4/7. Yes, Erica with the C. Okay, good. Okay, you don't think what? Sarah. Okay, so 4/7, 4/7. What happened to the negative? Well, a negative divided by a negative gives me a positive. Okay, those are the rules of integers. All right. All right, so where's the 3 coming from? Okay. Okay, have you done a lesson on dividing functions? Yes, I have. So, wish you have a great night, all. Oh, you too. I'll see you next time, misbehaving. All right, well, thank you. All right, so we found the y. Guess what we gotta find now? The x. So what we're gonna do is, since this is already set up for us, it even says x equals, and we need the x. So why not use that equation? So I've got my x equals 3 minus 4, and instead of a y, what's taking the place of the y? Yes, Micah. Okay, because we're going to be substituting again. Yes, the 4/7. And you're probably like, but Audrey, that doesn't go evenly. Hey, that is life. Okay, everything in life is not so even. Hello, Patricia. Lovely to see you. Okay, so now we need to multiply. So when you multiply a fraction with a whole number, this whole number is actually going to be over 1. So if I may, I got 4 times 4, which gives me 16. 1 times 7 gives me 7. So when I multiply the 4 with the 4/7, I get 16 over 7. Are we okay? The reason why it's negative, because there was a minus sign in front of the 4. So it's really a negative 16/7. All right. Now, what do we know about adding and subtracting fractions? Yes. Yep. Anytime you have a whole number, you always put it over 1. What about that 3? Y'all just going to ignore that it's not there? Yes, Patricia. We need to have a common denominator. Okay? We have to have a common denominator. So we need for it to have a denominator of 7. So I'm converting this whole number of 3 into a fraction that has a denominator of 7. Okay? Yes, Lisa. So if I multiply the 3 and the 7, that will give me, there we go, Lexi. Thank you. That will be 21/7. Okay? In order for me to add or subtract, I need to have a common denominator. I need to have a 7. So I had to make this whole number of 3 into a fraction. And remember, fractions is nothing but division. Okay? Even the fraction sign, even if you look at a division sign, you have the fraction bar and 2 dots. The 2 dots is supposed to represent numbers. You didn't know that? Right? How often do I go live? Right now, this week, I'm live 1 p.m. Eastern Standard Time and 8:30. That's Monday through Friday, and then 8:30 Monday through Thursday, Eastern Standard Time. Okay. Wait, how did you get 21 again? Not a problem. So I need to convert this 3 into a fraction, where the denominator is 7. So I had to think, what divided by 7 will give me a whole number of 3? It's going to be 21, because 21 divided by 7 gives me 3. Okay? So if you think about it, I need a denominator of 7. We have a whole number of 3. These two, you can actually multiply. And when you multiply it, you put your answer in the numerator. Okay, makes sense? Okay, good. So now, let's do our subtraction. Let's finish this bad boy out. So 21 minus 16, Lexi's saying it is 5 over 7. Okay, because when you're subtracting, let me erase this up. When you're subtracting, you're not doing anything with the denominators. You're keeping them the same, but you are subtracting the numerators. So 21 minus 16, that's where the 5 came from. Okay, there you go. But you can multiply both sides and cancel out the... No. We're not multiplying, Lisa. We are subtracting. Okay? We're not canceling anything out. Canceling out only happens when you multiply. Okay? So after we did the multiplication of that whole number of 4 with the 4 7s, multiplication is all done. Now we're doing what's in between, which is subtracting. Okay. And it's okay. But, all right. Okay. So, our order pair, the point of intersection, the reason why we're doing all of this lovely stuff is 5 7ths, comma, 4 7ths. Okay? 5 7ths and 4 7ths. So this is our point of intersection. Okay, she means multiply then divide. Okay. All right. So this is our point of intersection of those two. All right. Let's see if we can do one more, and then I can go and pass out. All right, so not too fancy, but let's just get right to it. So if I do, okay, we can do this one. So if I have, unzoom a little bit. Okay, so if I have 2x plus y equals 5, and then we have 3x minus 2y equals 11. Okay. You show the sheet in the paper. Of course, I can do that for you, Giselle. Not a problem. All right. Well, thank you for the follow. Hello, Evelyn. So if you also like, if you're trying to get your GED, your ACCUPLACER, also ASVAB, if you guys need practice with some skills, my friend Evelyn's in here with Impact Math Teacher. Go ahead and follow her as well. She's definitely on at 1 o'clock Central Time, and it's usually like right after I go. But she's been doing it a lot longer, so I just decided to go before her. And plus, it works for my schedule. Okay? All right. So, -3 on both sides. Pause. Okay. Awesome. She's good. Already follow her. Yes, Erica. I think that's how I got you. All right. So 2x plus y equals 5. 3x minus 2y equals 11. Now, the one that has the variable by itself is that top equation. We want to solve that for y. Okay? In order for the y to be by itself, that means I would have to subtract that 2x on both sides. Okay? If I'm trying to isolate my y, my 2x is positive, so I have to do the opposite, which is negative 2x. So the equation is going to be y equals negative 2x plus 5. Okay. Yeah, so we're going to solve the first one for y because y is already kind of by itself. We just had to do one thing for complete isolation. Okay. Oh, well, thank you, Micah. Appreciate it. All right. Okay. So now, since we altered that first equation, so that means the second equation is going to be the recipient of what y equals. So y equals negative 2x plus 5. So that means when it says y equals, this negative 2x plus 5 is going in for the y. So y is going out of the game and negative 2x plus 5 is coming into the game. That's how we're doing our substitution. Okay. So let's do this. So we have our 3x minus 2, and instead of a y, I'm going to give myself some room, equals 11. So instead of the y, I'm going to plug in my negative 2x plus 5. Okay. All right. How are we feeling so far? I'm confused. Okay. Which part got you? Okay. Not a problem, Micah. Thank you for stopping in. I appreciate you. True. Trust me. A lot of people love elimination. Trust and believe. But it's always nice to have both. SAT impact. Okay. All right. So, we solved the first equation for y by subtracting the 2x. Then we take this information and we plug in for y. So this y here is coming out and negative 2x plus 5 is coming in. Hence the parenthesis. Okay. All right. So when I distribute, I'm distributing a negative 2 inside everything. So I'm multiplying everything by negative 2. Yes. So we're going to actually distribute that. Okay, good. All right. Thank you. Set design. I love that. Thank you. What's a negative 2 times a negative 2x? What do I get when I combine those two? Okay, not adding, multiplying. So negative 2 times negative 2, that gives me a positive 4x. Good. How about negative 2 times a positive 5? So a negative 2 times a negative 2 gives me a positive 4x. And negative 2 times a positive 5, okay, good. Hey, Michael. Gives me a negative 10. Good. Bring down the equals 11. All right, since this was a positive 4x, we're going to put a plus sign in front because I need to bring down my 3x. Okay. Okay, so for those that were saying zeros and twos, when you distribute, you are multiplying. Okay, you are multiplying. So, combine your like terms. So since they're on the same side of equal sign, we can combine these like terms. So 3x plus 4x will give me what? Good, Yummy. All right. Oh, well, thanks. Yeah, 7x, 7x, 7x. Awesome. So we got our 7x. We're bringing down our minus 10 equals 11. Okay. What do I do next? Okay. These are adding. There's no negative because that 4 is not negative. A negative times a negative gives me a positive. So 3 plus 4, that gives me my 7x. Good. So we're not going to get rid of the 7x, but we are going to add 10. The reason why we're doing this is we're trying to get x by itself. Okay, we're trying to get, that's the main goal when we do these. We're trying to isolate our variable. So in this case, the 7x is going to come down. These two 10s are going to cancel out because you have a negative 10 plus 10. They cancel out. You don't need the 0 because you already have a 7x. The 0 is just a placeholder. So that means 7x is equal to 21. Okay. So how did we get our answer of 3? I'm seeing a couple 3s up there. How are we getting our answer of 3? Rotating those fingers. Ta, 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 ta. I appreciate it. Yeah, earlier this morning I only had like 2,000, but hey, there you go. So we're going to divide both sides by the 7. Because everyone had to go back to work. All right, so that means 7 divided by 7 gives me 1x, or just x, equals 21 divided by 7 gives me 3. So we found our x. Now we need what? Okay, we need our y's. Right, good. We need to find y. We need to find y, finding y. Okay, so since we have our x, let's go back. Boom, we already did the work to find our y. So remember, our y was equal negative 2x, but instead of an x, I'm going to put a what? Okay, so instead of the x, what's going to go in its place? Good, good. The 3's. y1. Okay, so we found what our x is. We're going to use this equation, which is y equals. We're replacing the x value because we already found what it is. So when we replace the 3, now let's go ahead and do our solving with the Christmas colors, right? So negative 2 times 3 gives me what? Yes, Lisa. There she is. This is so soothing. I try. Yes, there you go, Patricia. Here we go. So we got -6 plus 5. And then -6 plus 5 is equal to our -1. So these two lines are going to intersect at 3, comma, -1. So this is going to be our solution. Okay. Okay, as promised, I'm going to flip this over. So I think someone wanted to take a picture of it, which is fine. All right, let me see if I can unzoom a lot. Whoa, hello. Okay, I'm not sure who wanted it, but here it is. If you guys want to take a screenshot of it, you can. Okay, great teacher. Thank you. I don't know if I got one more in me. This is the reason why I'm like going to bed at 2 o'clock. Brought back memories of teaching my boys. Aww. Okay. All right. Please, please. All right. And then someone needed the back. Here's the back if you want to take a screenshot. I mean, you say it so nicely. All right. Okay, thank you so much again. You explained so well and thoroughly. Not a problem. Oh, want to tap to 2. Oh, it's a 25K? All right. I'm a math teacher. I speak French right now. I live in the U.S. I want to teach math. What I have to. What you have to. So what is it that you need to teach math, or do you want to tutor math? There is slightly a difference. Because to teach math, you definitely need to have your certification, all your schooling, all that cleared out. For tutoring, especially in the States, you really don't have to have a certification to tutor in the States. But you definitely got to learn to build up your brand, show some sample problems, do what I'm doing right here, what a couple of us are here to go live and show what you can do. Okay, and then it's going to be up to the people that they want you, they'll get you. All right, one more. Yay! I can hear the celebration all the way from here. It's crazy. All right, here we go. Last blessed one. Because, dudes, I've been tutoring all day, dealing with crazy crazy emotional stuff. And I came on the live. I lost a former student. Enough with the guns, people. Just enough. All right? I don't want to keep losing any more kids and stupid GoFundMes. I'm tired of it. Okay? All right. That shadow of the phone blurs your page. I know. But you know what? This is what I got. And this is what I got to deal with. Right? You know? This is all the emotions. This is it. Because if anything, I'll see if I can. Let's see if this works. Okay, that's a little bit better. I just look like I'm like in the basement or something, but here we go. All right, that's okay. Yay! All right, so great, better. Oh my gosh! All right, here we go. Now we have 5x plus 7y equals 1, and we have x plus 4y equals -5. And someone, because I like to give credit when credit is due, I think someone mentioned, who said it? Someone said, oh, subtract 5 from both sides. Not the 5. What's next to the x? That's what we want to isolate this x. We want x to stay right where it is. So that means our 4y needs to come to the other side. And how I get that 4y over, I do the opposite. So since it's a plus 4y, that means I want to subtract 4y. Whatever I do on one side of the equal sign, I must do in the other. Okay? So this plus 4y and the minus 4y, these cancel out. So now my equation is going to look like this. It's going to be x equals, slide that over a bit. So x equals, we got -5 minus 4y. So that's what x is going to equal. Okay. Ooh. Thank you. Yeah, I'm just a little, okay. All right, doesn't matter if we solve for x or y. In this case, you would solve for the one that doesn't have a number in front of it, that doesn't have a coefficient. It makes life so much easier. You can solve for y, but then you're gonna have to divide, and like you said, you guys don't like fractions. So why put you in that fraction state of mind, right? All right, so now with this bit of information, that means this -5 minus 4y, I'm going to substitute it for x in the other equation. So this is going to go in for the x. So when I rewrite it, it's going to look like this. I have my 5, then I'm going to put a parenthesis because that's where this stuff is going to go. Plus 7y is equal to 1. Let's see if I can shrink it down a little bit. Okay, so this stuff is going to go in for the x over here. So then we're going to rewrite, and we're going to put that -5 minus 4y inside for x. So this x is gone, and this -5 minus 4y is in its place. Okay. I know. There we go. That might work a little bit better. All right. Okay. So now we're going to distribute. Okay? So we're going to distribute. So 5 times -5 gives me -25. 5 times -4y gives me -20y. And now I'm bringing down my plus 7y equals 1. So now I'm tackling this equation and I'm solving it for y because that's the only variable that I have in this equation. So right here, we have like terms. So -20 plus 7y gives me what? Don't we have to group now? We're not doing grouping. Grouping only happens when you have 4 terms. So we're not doing grouping. Okay. So -20 plus 7, since the signs are opposite, I'm really subtracting. So that will give me a -13y. Bring down my equals 1. Bring down my negative 25. All right. Okay. So we're trying to get y by itself. So that means this negative 13y is going to stay right where it is. Okay? The negative 25 is driving us crazy. So we're going to do the opposite, which is add 25 to both sides. Okay? So negative 25 plus 25, that gives me a 0. We're bringing down our negative 13y. And then over here is going to equal 26. Okay. Good. Good job, Pooh. Pooh baby. Now we need to divide negative 13 on both sides. There we go. All right. So let's divide negative 13. Okay, maybe not this color next time. Because even I'm like, what? Let's try this again. So we divide negative 13 on both sides. Okay, negative 13 divided by negative 13 gives me 1, or y. And y equals, what we got? 26 divided by negative 13. Hey, Pam. 26 divided by negative 13. What would we get? Okay, got a negative 2, got a negative 2. Okay. All right, you. Okay. So, good. So, 26 divided by negative 13 does give me a negative 2. So, that's what y equals. So, now we need to get our x. So, we said the equation of the x was simply x equals negative 5 minus 4y. Okay. Instead of the y, we're going to substitute the negative 2. Because that's what we found for the y. All right. Now, please excuse my dear Aunt Sally. We have to do the multiplication before we do any addition. So that means you have negative 5. Okay. A negative times a negative gives me a positive 8. And then negative 5 plus 8, that gives me a positive 3. All right, what's the name of this problem? This is, what am I doing? Substitution. I'm like, what am I doing? Systems of equations using substitution. Okay. So that means my ordered pair is not going to be negative 2, 3. Remember, x comes before y. And this is going to be my solution. Okay. Okay, do elimination. Yes, we can do elimination, but I'm not doing it tonight. I don't like to teach too many different processes in one night. It gets confusing. So B, no. Good. Do you tutor calculus? I do not, but I do have a guy. Okay, so any system of equations, we can use the method of substitution. Yes, you can. Yep, you can do, remember, there was 3 of them. We can do graphing, we can do substitution, and then for tomorrow, we're going to do elimination. But this is the best part. We're going to do elimination and word problems tomorrow night. Okay? Gotta get these word problems under wraps. Okay? Sure. Let me see if I can get all of that. There you go. Okay. When will you restart this course? Probably. Okay, what is this? This is basically March. So probably maybe around June. Okay, May, June, around there. So I'll definitely start back up. I'll switch everything up like around the summer. Okay. Oh boy, I know, oh boy. I missed the beginning. We'll be able to find this live on YouTube. If I can download it, if everything works out, because right now it's not working out. You're a teacher? Yes, I am. Certified teacher, but I'm no longer in the classroom. I want to tune in from the beginning. Thank you for doing this. Not a problem. Yep. Is it true that elimination is easier? Oh, yes. Oh, yes. When I thought, oh, good evening. How are you? Yep, the grind never stops. Definitely. Nope, it never stops. Yep, as soon as I get off of this live, I'm going to have to go back to a lot of things. So if you want, I can like show you guys, if you guys want to take copies of the beginning, if you want to take pictures of it, especially those that were here a little bit late, just let me know, then I can flip. I'm good, just relaxing. Okay, cool. Good. Thank you for the time and community teaching of TikTok. Oh, no. Thank you for pushing people to tap. I appreciate that. It's like one less thing I have to worry about. And if anything, before you guys go, if you like how my pages are formatted, so this is one, this is another. For those that do not know, I created this. This is actually inside of a book, okay? I created my own math notebook. So if you ever are interested in buying it, it is on Amazon. So what I do is I'll have like some work on one side. The other side will be the other grid. It gives you enough room to do more spacing. Now, for those that were struggling with their multiplications, we have this. This is called a factor chart. Okay, so you do all the factors, not only from 1 to 100, it's 1 to 200. Okay, so when you're dealing with the larger numbers, you can look up their factors. It helps you with simplifying radicals. It helps you with factoring. Okay, it even helps with general multiplication. The numbers that are highlighted in yellow, those are your prime numbers. In blue are your perfect square roots, your perfect squares. Okay. And also, some of you guys were having some time with the rules of integers. These are your examples and also the rules for addition, subtraction, down here multiplication and division. Okay, as we go into word problems for tomorrow, that's in here. Also, hey, look here. Okay, got the rate of change. We got standard form. We were talking about that today. The slope-intercept form, we talked about that today. Then we looked at the properties of exponents, orders of operations. All of this is in here. So people that are going to trig, this is in here. Pythagorean theorem, SOHCAHTOA, sine, cosine, tangent, the identities. If you're dealing with geometry, you're dealing with volume and surface area, that's in here. Okay, yes, word problems for tomorrow. And for those that are taking Algebra 2, you're definitely going to be seeing unit circle. If you haven't seen it already, it's coming. All right, all of this is all packed into one. So just like anything else, if you need a moment to just kind of regroup, I also added some brain break activities. So sometimes you just want to mindlessly color Maybe do a couple mazes just to kind of help get that brain flowing again. If you're into pixel art, you got some space to do some pixel art, or even doing some sketching. All right, so all of this is under one folder. As you can tell, if I wanted to do some graphs, like say it's a piece of paper that your teacher gave you, you can cut them up and then do the different types of solutions on one side. And I also got that on the other side. If it's a full sheet that your teacher wants you to have, you can tape it on one side, and then the other side, you can summarize what is on that piece of paper on the other side. So you can have everything right here, okay? So, yes, thank you, B. I appreciate it, okay? Don't tell me that. All right, yep, it's coming. It's definitely coming. Okay. Oh, yeah. I'm able to draw my graphs. Yes. Because it really makes your graphs so much easier. Like, especially on the dot side, I'm going to actually be releasing another copy of the book with some more resources. So that's not going to happen for like a bit. But if you ever want to, if you got like an open notes quiz, you ever like get an open notes quiz? That's why some teachers love open notes quizzes, because they know you're going to be flipping through tons of paper and you have no idea what you're looking at. But with this, it gives you your formulas right away. Then you can write down the steps on how to solve. And then you have your examples all right here. Now, studying math is not just you taking it and just flipping through the pages. That's not how you study math. You literally have to have your problem. You can use your notes, get a piece of paper, okay? Write down the problem on the piece of paper, take away your notes, focus on the problem, do it on that separate sheet of paper, and then bring your notes back to use as an answer key. That's how you study math. You study through practice. You don't just study by flipping through pages. That doesn't help you at all. Okay, so why are the gray dots used for? It's so much easier to graph because now I can plot points. And then it's not so intrusive that when I start doing my problems, it doesn't get very overwhelming. Because even when I do with just like, say, regular graph paper, it's okay. But I noticed that unless I write inside of the squares, it's almost like if I have a negative and I put it on the line, if I wrote that out in gray, it would kind of blend in. And then I wouldn't be able to see the points. So that's why I kind of like doing with the gray dots. It's pretty awesome. Thank you. Okay, nothing to it but to do it. Exactly. All right. So if you do want to purchase one, they are on Amazon. Ready to go, and you'll get it delivered. For some reason, people get theirs delivered so much quicker than mine. But that's all right. That's okay. All right. So I am done. How you guys doing? Are you ready? You're welcome, Michael. Not a problem. I appreciate you guys coming out. We did quite a bit, which is good, with the substitution. So as promised, tomorrow we're going to be working on elimination. And you're probably going to be like, oh my gosh, this is so much easier. As well as we're going to do some word problems, how to break these concepts down. All right. So how do you know what numbers to plug in for y and x? Do you always start with 0? No. It always... So what to plug in, you're going to have to solve first. I love the tables with factors. Awesome. That's a big help. Good. 1.8 more taps class. Oh, you're so awesome. Okay, have a good night. Have a good night, B. Okay, thank you, Audrey. We appreciate you and your time. I know how valuable your time is. Oh, thank you. Okay, what time do you normally come on? Because I always catch you at the end. Yes. So 8:30 Eastern Standard Time. Okay, Monday through Thursday, 8:30 Eastern Standard Time. It might be changing next week because I'm starting to get more students, and this is when I'm starting to get my wave. But I definitely want to offer that 1 p.m. I'm here, as well as 8:30 p.m. Okay. Oh, thank you. Oh, that's so sweet. It's been a minute since I gotten flowers. All right. Okay, got it. Awesome. Okay, everyone. I have an exam tomorrow, and this helped a ton. Good. Have a good night's sleep. Subscribe on YouTube. Yay! Thank you. All right. Well, hey! How are you? Are we still a go for 12 tomorrow, Professor TK? Yeah, because I'm just about to wrap up. I started at 8:30. We're working on almost, Jesus, 2 hours. Crazy. Sorry, I missed your live. I was driving. Not a problem. Yes, ma'am. Okay, cool. So I will send you... I think I can send you the link. If I can't send you the link, I'll send you my number so we can text and I can send you the link for the thing. Yay! Thank you so much for the taps and thank you so much for the likes. I appreciate it so much. Okay, have a good night, everyone. Good night. Night. Rest up. Enjoy your life. And I'm just going to clean up my mess and try to find where my cats are. I think they're doing some cat stuff. Tap a little bit more. Yep, we're almost there. Almost there. Just like liking myself. No, it's just right on the cusp. Yeah, I had like 6 people earlier today. And I was like, oh yeah, I forgot last week was a holiday. So that's why so many people were there. Mine said 29.8. There it is. Now mine said 30. 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 But up. Okay. All right, everyone. We hit our goal. Thank you so much. Have a lovely night. My phone is about to die. So I will see you tomorrow, either at 1 p.m. Eastern Standard Time or 8:30 p.m. All right. Take care. Bye now.